So now if we're looking at that Coulomb's law, for the force, what we've got is that we've got pairs, and the net force is equal to the force due to charge 1 plus the force due to charge 2 plus the force due to charge 3 plus the force due to charge 4, etc.
But this one only goes up to how many charges you have, so
Goes up to however many charges you have. Now, mathematically, we can write this as the sum of all the forces from I equals 1 up to n, the number of charges you have. So this is the summation sign. Now, I'm going to grab some equations from the book and again come up here and take a look at this. And just sort of break this out a little bit. So I'm going to paste it in a couple of steps here. So I'm also going to add to that our base equation. So each one of these forces involves a QI, a separation I, and a unit vector I, but the same capital Q. And so they went ahead and immediately pulled out the 1 over 4 pi epsilon naught. And then they said, oh wait, we can pull out the capital Q as well, because it's common the test charge and the 4 pi epsilon naught.
So once they pull that out, the big Q would just be outside. But where does the 1 go? Like,
Okay, so like the Q1, R1, Q2, R2, Q3, R3.
okay.
So when we look at the individual forces, the force 1 was 1 over 4 pi epsilon naught Q1 capital Q R1 squared R hat.
Okay.
And the force 2 is the 1 over 4 pi epsilon naught Q2 big Q R2 R hat 2.
Okay, so it just goes on.
Right. And so we could rewrite this as the net force, which is a vector, has Q over 4 pi epsilon naught, the summation over I of QI over separation I squared unit vector I.
And I represent the number.
I represents the index of the individual source charges.
So if we was doing, so the one we have right now, since it has a Q, it has Q1, Q2, and QI. Will we start, okay, so we leave the I right there, and the next one we would just go with the Q1, then the Q2, and that's when we'll stop?
Mhm.
Okay,
So depending on what you've got in terms of your charges, the number of charges, so if you've got two Qs, then you'd have, if n is equal to 2, you'd have a Q1 and a Q2. Now, we don't add the charges, we add the forces. If you had 5 of them, it'd be Q1, Q2, Q3, Q4, and Q5. In general, for unspecified n, it goes all the way up to Q1, Q2, ... Qn. Okay? And Qi is the individual ones.
so QI is the first letter to start with?
So Qi is the number, so whichever first one you've got.
Okay.
Okay?
But where the N came from?
So if n is not given as a number, you just go up to Qn. N is the number of source charges you have. This just comes back to nomenclature for summations.
So does the number ever stop?
It's depending on the problem.
Okay.
Okay? And so what n is, for your specific problem, you might have n equals 2 or n equals 5 or just n if you've got a conceptual problem. And so it just sits there and it goes from I equals 1 up to n. So if they just do the summation over I, you're not specifying how many you have. But if you've got it fully here, n is the number of charges. Now, we're not going to fully get into it today, but I said that we were going to start taking a look at the electric field. And so I'll just preview for you here in the textbook. What they say is that if you've got these multiple charges and you pull out the big Q, since the electric field is defined as the force per test charge, that means this must be the equation for the electric field. And that came back to that definition we had from General Physics 2, where we said the electric field is defined as the force on a test charge at any field point.
Electric field is
Defined as
The force
charge
on a test charge
on force on the test charge.
at any field location. Okay? So we will come back and take a look at this in terms of the electric field. Again, that will be for a future lecture. So this kind of just sets up how you're doing it conceptually and mathematically.